we're solving problem 21 from the 2024 AMC 12A solution 1. Suppose that A1 is 2 and the sequence A sub n satisfies the recurrence relation A sub n minus 1 over n minus 1 is A sub n minus 1 plus 1 over n minus 1 plus 1. For all n is greater than or equal to 2, what is the greatest integer less than or equal to this expression here, this summation? So what we can do is, well, first the problem says we want to find the greatest integer less than or equal to. Well, we know that the greatest integer equivalent or less than to this expression would be the one equivalent to it, since the problem doesn't say anything about an integer being greater than this value. We can then start simplifying this equation by just multiplying this over. Well, these ones cross out. So then this side becomes n times a sub n minus n equals, and then multiply this one over, n minus 1 times a sub n minus 1 plus n minus 1. We can move this n over here to get 2n. And the key aspect is that we see we have a 2n and a minus 1. What we can do is complete the square. So we're going to need a minus n squared here, because usually this would be plus 1, but this is minus. So we want the signs reversed. So then n minus n squared, to cancel out the n squared, minus n squared, we're adding on the other side. N minus 1 a sub n minus 1 minus n squared plus 2n minus 1. This whole expression then gets simplified down when we complete the square. This is n minus 1 squared. So what we can do now is we set value b sub n to be n sub a n minus n squared. So we know that this value n a n minus n squared is equal to b sub n, which is also equal to b n minus 1, and all the way until you subtract 1 from every integer, until you subtract all the ones from n until it's just b sub 1. It says that n has to be greater than or equal to 2, but here we have this value, and this is true. What this says is that this is the smallest value of n. When n equals 2, this value is going to be 1. Henceforth, we can say that a sub n is equal to 1 over n plus n. So therefore, squaring it gives us 1 over n squared plus n squared plus 2. So then we use that equation, squared. We plug this into that equation for the bounds of n equals 1 and 100. We have to sum up the squares from 1 to 100. And then add 2 times 100, and then add all these squares of all the reciprocals of the squares of 1 to 100. So this is 1 squared, that's just 1. Add 1 over 2 squared, and then all the way until you add 1 over 100 squared. This value, when you simplify it, simply becomes 338,551, which is our answer for this problem.